Hello, my name is Matthew McKnight. I am a programming mentor for Team 4536, the Minutebots and the Millisecond Bots. And we're going to use part 2 of writing the DriveSystem code to explore some common aspects of programming, specifically enums, constants, and refactoring. So let's get started. Last time, we developed the instantiation code for the DriveSystem. And in the process, we required 4 parameters to be passed into us, all 4 of them DC motors. We then assigned those parameters to the private variables for the right front, right rear, left front, and left rear motors. This is very nice, very clean, very obvious instantiation code, but now we have to move on to the next stage of this. And that is that we have the motors, but we want to initialize them. We want to set them to a beginning state. We want to do that because that is our concern. All that stuff could have been handled outside of this code, but it would not have really represented separation of concern. So we have these motors, they've been created outside and passed to us, and now we actually want to initialize them when we start. So there's a couple things we're going to do here. This session is going to be about what is known as setting it to reverse or forward in its direction. I'll give an example later on, but the short version is motors on these robots tend to face opposite directions. So the right motor is facing the opposite direction from the left motor. One way to think about it is if you and your friend were standing back to back, that is how the motors are facing. And if you twirl your arms in a clockwise direction, you'll actually be twirling your arms in opposite directions in relation to the robot. And what the robot will do is one wheel will spin forward, one wheel will spin backwards, and it'll just spin around in circles. So the problem is that both motors turn counterclockwise, which would be fine if they were facing side by side, but they're facing back to back. And what that means is that one will turn in one direction, the other will turn in the actual opposite direction, and the axle will simply spin around in circles. So the right one will roll up, and on the left, it'll roll down. The result is that the robot simply spins around in circles. So we'll see how people have devised a way to make it easy to resolve this issue as we go forward. And in the process, we'll learn about things like refactoring and enums. We'll talk about things like constants. And so this is a way to really grasp some of those key ideas. All right, we're going to get started here. And what we're going to do is we're going to set the m_drive motor left rear. We're going to set the direction to reverse. Now notice when I type this set direction, by default it gives me a direction out of DC motor simple, and it sets that really strange reverse on the end. That's because this is what's known as an enum or an enumerator. We'll talk about that in just a bit, but enums are very useful for controlling the information that flows into our class so we don't make mistakes. M_drive motor left front set direction is going to be the same. I'm going to capital D it so it'll recognize and give me the IntelliSense bit. And I'm going to set that one also to reverse. So with this code, what I've effectively done is I've said the 2 left motors are going to spin in opposite directions when given a positive as the 2 right motors. And what this will do is it'll affect that both motors on the right and the left, when given a positive number, will actually spin in the same direction in relation to the robot. They'll either go forward or backwards. Now, as I said, direction is an enum. Enum is like a multiple choice option. You can choose A, B, C, or D, and nothing else. And what that does is it enables the coder to control the information that's coming in, so that people will not put in information that is confusing or a mistake or takes time to figure out. Before we get too much farther, I want to stop for a moment and talk about 2 things that you're going to run into a lot when you program: constants and enums. These were designed to make programming more robust, less capable of breaking. Constants they're stones, they're rocks, they are unchanging. Enums are more like multiple choice options. For example, what is your favorite pizza topping? And you will have 5 choices in there: pepperoni, mushrooms, anchovies, sausage, and artichoke hearts. You can only pick one with enums. So constants and enums are central, and we're going to use them in this video So keep your eye open for that. Constants, like I said, are a variable set in stone. They're a variable which is unchanging. And there's only one of them. This is accomplished by using two keywords when you declare the variable, static and final. Static means there's only one, and you can reference it without having to instantiate anything. It's just available. Final means it is unchanging. It is the rock. You cannot change constants. A good example of a constant is found in the math class, and it is everybody's good friend, pi. Pi is never going to change, no matter how hard you try. It is therefore the perfect example of a constant. The conventional format is to write the name of the constant all in caps with underline between the words, such as, this is a constant. Imagine that somebody's having issues with their phone and everything is coming over capitalized. That's what this looks like. This is just a convention. Computers don't care what we call it or how we capitalize it. But what this enables you to do is when you're looking in code and you see something that's all caps, you know it's a constant. For example, if you look up at the math.pi, you'll notice that both the p and the I are capitalized in pi. It's because it's a constant. Enums are a multiple choice. They're declared like a class but not instantiated. And by this I mean, here's my example. Public enum, handedness, left, right, and ambi are your three choices. I'm not going to create a new handedness. Handedness itself is actually a static class, which means that I can access it anywhere. It is also generally final, so whenever you see an enum, assume that it is both static and final, similar to a constant. Often they are declared inside the classes which they reflect. In other words, enums generally don't float around by themselves. There's not much reason for that. They are used by the classes which contain them. So, for example, math.pi, or here's another one, java.time.dayofweek. Day of week is a enum that is directly tied into time, and so it is declared within the java.time class. I want to take a closer look at enums because they can be a little strange to wrap your brain around the first time. The key about enums, what makes them very useful oftentimes, is they allow control over the parameters that are used in methods, that are passed in and moved around in methods, by limiting the choices of what those parameters can be. Like constants, they are static, as I mentioned, and they are usually final. This means that you do not have to instantiate anything to access them. You can just access them directly, and we'll do that in the video when we access direction. They're a multiple choice option, and you cannot add options or take them away. That's both a strength and a weakness. And they're generally referred, when you name them, again, this is naming convention, they're singular, not plural. So day of week, not days of week. And by default, they're what are called zero-based, as many things in programming are. And that means if you looked at the right, pepperoni would be of value 0, mushrooms of 1, anchovies 2, sausage 3, and artichoke hearts 4. But even though they are generally zero-based, they do not have to be. For example, pepperoni could be assigned a value of 4, and mushrooms 3, and anchovies 27. As long as they don't share the same number within there, it's totally fine. You can actually declare them. But generally, their purpose is not to hold the integer number that they're connected to, but to represent a choice which you will then parse out. Here's an example. Public enum, primary color, with the options red, blue, and yellow. I cannot add to the primary colors. But if I try to use this, for example, say primary color my fave equals primary color red, the problem is my fave is actually orange. But I can't add orange in. I'm limited by my choices. Here's another example. Planet, public enum, planet, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Where's Pluto? Sorry, Pluto, you aren't a planet. So I want to go through an example of how you would set a enum at a non-zero based. And this has actually happened in the day of week example that we saw in Java time. Monday is 1. And if you do it like this, Monday equals 1, then Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, it just rolls down. Monday is 1, Tuesday is 2, Wednesday is 3, Thursday is 4, Friday is 5, Saturday is 6, and you guessed it, Sunday is 7. This is useful because if you want to refer to the first day of the week, ordinal number 1, then you're doing Monday. If it were the 0th day of the week, that'd just be a little confusing. But that's just a little quick background on enums and constants. I hope it'll help as we go forward. Let's get back to the video. Oh, Robbie! So we're going to take a quick look up on direction in DC Motor by going to localhost. And what that will do is actually bring up a website on our computer, a web page, which will tell us information about this enumerator, DC Motor Simple Direction. Remember that I said there's multiple choices, where in this case there's only 2. You're either doing forward or you're doing reverse. Those are the only 2 ways a motor can spin. It's either going to spin one way or it's going to spin the other. And so by setting this up, we can have a lot of control over the information that comes in. There's not going to be a third option that people are going to put in. They're not going to try to spell forward and have us try to understand. We're going to know exactly from the moment we receive this what the choices are. So enumerators are very, very powerful, and you'll run into them a lot as we go forward. So we could leave it like this. This is pretty well hard-coded, however. And generally you don't want to hard code unless you're sure. By hard code, I mean that you set in the body of the class, for example, something that you have to go in and change later. Whether a motor on the left is reverse or going forward is not necessarily going to be determined by this code. It's actually going to be known outside of this code. So understand that even though we're initializing it on the drive system, somewhere else has to tell us what that is. And so the simplest solution for this that we're going to work with is use a constants class and then use that to determine whether the motors on the left are supposed to be reversed. So I'm putting in this line, if constants.driveMotorsLeft are reversed, then, and I'm putting the squirrely brackets around, run this code. In an if statement, the things between the parens must be a boolean, a true or a false. If it's true, it'll run the code in the squirrely brackets, and if it's false, it'll just skip right over it. So that we have the constants file, if you remember from when we first set all this up. And if I right-click and hit Alt-Enter, I can say that's what I want to use, and it will automatically import it. Remember, we have to import classes that are not in our package. If we go over to constants, that constant does not exist. So we're going to hit Alt-Enter, and we're going to create the constant. Drive motors left are reversed. Notice that it's all capitalized with underlines between all the words. That is how you designate, according to convention, what a constant is. Constants are things that are set in stone. Think of, for example, pi. Pi is going to be a constant. Another constant might be the number of rotations, maximum number of rotations that a motor can run on. So we've got this set up, and it's nice, except I'm going to think in terms of organizationally, there's going to be a lot of constants possibly in this robot, setting up all the different systems that we have, doing all the different plans that we have. So maybe what we need to do is actually break this down into a simpler organizational structure, break things apart. In this case, what I'm going to do is create what's known as an inner class, public class DriveSystem info. That means that within the class constants, there is actually another class. And the only way to get to that class is to go through constants. DriveSystem info cannot exist on its own outside of constants. Now, if you go in here, there's going to be a problem because now it's no longer referencing constants. It's referencing the class constants.DriveSystemInfo. So this is a way to set this up, which will make it easier going forward. For example, we might have a public class for the intake called intake system info. And by splitting these out, I'm not digging through the entire constants file trying to figure out where the intake system constants are going to be located. So part of good programming, like we've talked about before, is good organization. All right, now we have the constants for the drive motors left or reversed, but what about the right? Is it possible that maybe those might need to be reversed? Of course it is. So what we're going to do is exactly the same thing. We're going to go into constants.DriveSystem, and we're going to generate a constant called drive motors right are reversed. And if that is true, what do you think we're going to do? Same thing we did with the left drive motors, only this time to the right drive motors. This enables us to reach outside of our class to find the information we need and then implement it. We aren't letting anyone else set the direction of our motors. We're setting it. Are concerned, but we are letting an outside source tell us what the motor direction should be. Now I'm going to switch it up here. I'm going to set the M drive motor right rear set direction, but what I'm going to set it to is the direction of the M drive motor right front. So what I'm doing is I'm using a get direction to pull out of the M drive motor right front, which is now reversed because we just set it, and then I'm going to set the M drive motor right rear to that direction. This is a setter and a getter. So again, as we talk about, when you do encapsulations, settings and gettings are pretty common ways to expose, ways to interact with the class without giving you direct access to the class. In this case, we see them in the same line. You don't have to do this. I could simply say M drive motor right rear dot set direction paren DC motor simple dot direction dot reverse. That would work. But I wanted to demonstrate how set and get work together. I'm getting the direction of the right front, and I'm setting the direction of the right rear. Notice, by the way, we haven't quite finished yet because we still haven't set up the constant drive motors right are reversed. But do remember that sets and gets are a constant thing you're going to run into and want to leverage in terms of encapsulating your class, in terms of protecting your class and building that wall around it. All right. Let's go up and let's set that constant that's been sitting there looking red at us for a while by hitting Alt-Enter and create the constants field. And in this case, I'm going to set it to false. All right, here's the question for you. Looking at this code, looks fine, but I'm actually missing something. I'm making a mistake that may come back to bite me. Think about it. See if you can figure out what it is that I've left out that I should do here. In the meantime, let's move on to the concept of refactoring. Now, in my DriveSystem instantiation code, I could leave this in here, but I really don't want to. Mostly what I want to do in my code is I want to see from a high view what I'm attempting to do. So what I'm going to do is I'm going to create a method called set reverse direction. And it's red. If I hit Alt-Enter, it'll allow me to create the method and do it for me. It's private, so no one outside can see it. And I'm actually going to cut this code and stick it into the method. So what happens is the instantiation method calls this method, and therefore really this code doesn't change anything. It's the exact same code. The difference is that this is much easier to read. If I look at the instantiation code, I can see what I'm trying to do rather than trying to break it out chunk by chunk by chunk. I've taken this chunk out, I've put it somewhere else, and that enables me to see here what I want to do when I glance at the instantiation. If I actually want to see what is going on with reverse directions, then I can go into that method and fix it. I don't like the name of this method, by the way, because the method doesn't actually tell me anything. It tells me something's got a reverse direction going, but I really don't know what it is. So part of what I'm going to do is I'm going to change this method name. Instead of simply saying set reverse directions, I'm going to change it to set reverse directions on drive motors. Remember, I'm not afraid of long names. Set reverse directions on drive motors if needed. And because it's red, because I haven't changed the method itself. So I changed the method name itself, and now it's fine. As it goes to the instantiation code, it will assign the motors to the private variables, and then it will set the reverse directions on drive motors if needed. That's pretty straightforward. That's pretty nice. One thing to think about with refactoring is it's not just to make your code cleaner to read and easier to understand. What it can also be used for, and what it's heavily leveraged for, is when you are repeating yourself in code. When you're calling the same basic process over and over and over, then it makes sense to take that process, extract it, refactor it into a method, and then call the method. That gives you a lot more leverage, and if things work and you have to change something, you can change it in the method rather than go through one by one all the things you cut and paste. Cut and paste is not a great thing to do when you're coding.